Hello, welcome to the GOTO Book Club. I'm Stuart Marks. I work on OpenJDK, and I'm here with Maurice Naftalin. And Maurice, why don't you tell us about yourself and about a new book you have coming out?
I'm Maurice Naftalin. I've been working in software development for a very, very, very long time. About half of that, I've specialized in Java. And the book that we're going to look at today is the second edition of a book that I wrote with Phil Wadler, also quite a long time ago. We wrote this book for Java 5 when generics first came out, and the collections framework was by then about 7 years old. This is a long time ago, and we've had time to look at some experiences since then. And that's what the new edition is about. Stuart and I wrote this sort of together. Phil and I are still the main authors. Stuart was the technical editor on the book. But I think of him as being close to having been a co-author.
Well, that's very flattering. So let's see, do you have a copy of the book handy? I guess we have to do the obligatory. I don't know if it shows up backwards there, but there it is.
It was
the second edition of Java Generics and Collections. So you said it was for Java 5, and so we are almost at the release of Java 25. Now, the version numbering has changed around. That really has been a gap of nearly 20 years since the publication of the first edition. So what led up to creating the new edition?
Well, actually, it's quite nice. I don't know if this is the first time I've noticed it, but it's 19 years since the first edition was published, and it's 19 versions of Java later. Java 5 to Java 24 right now, about to be Java 25. Well, quite a lot changed. So the thing that really kind of convinced O'Reilly that it really was worthwhile having a new edition was the advent of sequenced collections, which you may have heard of, Stuart. You could say something about that now.
Yeah. Okay. So sequence collections is a new set of interfaces that was added to the Java Collections framework that was integrated in Java 21. So I did that work. And so that's why Maurice is suggesting that I talk about that.
The other way that I pushed it towards O'Reilly was because I thought that the advent of streams, ever since I wrote about streams in a book in 2013, I thought that this book would require revision. The collections part would require revisions because streams have changed the way that we think about bulk data processing in Java. And it turned out that actually that wasn't as big a change to the book as I expected. The basics of working with collections hasn't changed greatly, and about most of what happened was that I found alternative ways of writing many of the examples that included streams, and some of those are in the book as well. What surprised me also was the extent to which, although all the code from the first edition was still valid, apart from a certain number of mistakes, was the fact that the style had altered a great deal. And so, for example, the advent of records meant that many of the examples look quite different, that the fact that we no longer use constructors for the wrapper classes, we had lots of examples that used new integer, which is currently deprecated and may stay deprecated. Again, that's up to Dr. Deprecator here, aka Stuart Marks.
Yeah, that's one of my other roles is to deal with deprecation in the platform. And so sometimes I have an alter ego, Dr. Deprecator. Unfortunately, he's not here right now, but so he sends his hellos.
Well, we in that case we can badmouth him because Dr. Deprecator has deprecated the integer constructor and is liable to undeprecate it again later on, as far as I understand it. But I took those examples out, and that required quite a lot of changes to the code. And then I went back and then once you start working with something and looking at, say, rewriting the examples a bit, you look at the original material and you think, well, actually, I think this could have been improved. This could be improved a bit. And so I ended up doing quite a substantial rewrite of many of the chapters, even in the generics part of the book, which I thought originally would be able to remain fairly untouched.
So I think another thing that has changed a lot over the years is the emphasis in Java programming on immutability and unmodifiability. And so I'll take this opportunity to mention another enhancement I made to the collections framework, which is a set of factory methods and implementations that support unmodifiable collections. And so that went in a long time ago now. That was in Java 9. And so that's list.of, set.of, and map.of. And those appear in the examples a lot as well, don't they?
I should have mentioned those. I mean, and in many cases, using constructors for collection instances, when you know that you aren't going to want to modify them, now doesn't look like modern Java. So examples needed changing in that way as well. I mean, generally speaking, you would look at the first edition now and you would say, this doesn't feel like the same language that we're writing in anymore, even though it's quite valid. If you add together the changes that I mentioned, records, the unmodifiable collections, the deprecation of the wrapper class constructors, altogether, you put that all together and it looked pretty antiquated. So there had to be many changes there. And I think probably of those, the one that is the most significant in terms of the overall thrust of the book, it would be the unmodifiability, the move towards immutability and the introduction of the unmodifiable collections.
Yeah, there's definitely a style change or stylistic change in the way Java programs have been written over the years. Certainly the collections framework has always supported mutable collections, and certainly it's possible to write a program that adds elements to a collection and then removes them and then searches them and inserts them and so forth. But people still do that probably, but I think with the advent of streams, if you want to transform the elements of a collection, typically the style is to take the elements, run them through a stream, and then deposit the resulting elements into a different collection. And so you're ending up copying things. And that goes hand in hand with unmodifiability, because you create a new version of something with different contents instead of editing things in place. Although that is still possible. And so I think that sort of leads us to one of the topics that we wanted to cover that is covered in one of the new chapters in the book, which is usage guidance. And so since it has been such a long time since the first edition was published, we now have quite a bit more experience with using the collections framework. So did you want to mention some things about what that chapter covers?
Yeah, well, I mean, one thing I should say in answer to the point you just made is that we're probably doing less mutation in Java than in the past. I mean, I don't think there was any idea of trying to reduce mutation when in Java 1.0 or 1.1 or so on. But by the time it came to Java 5, with the advent of the concurrent collections, immutability was being seen as much more useful. And there's really been quite a steady trend towards adopting the features of functional languages into Java, and not only the features but also the ideas behind functional languages. So there has been this movement in that direction. I've given talks. You might have seen one that I did with José Pomar on how Java's kind of borrowed from functional languages. But it's important to say that, Java's not a functional language. It wasn't designed as one, and it never will be one. We will always be doing mutation. And that's really baked into I was going to say baked into the DNA of the language, but that's mixing the metaphors a bit. Once you've baked your DNA, it doesn't work so well anymore.
That's right.
So the features in the guidance chapter, that's new in this edition. We've kind of this edition fleshes out the kind of bare bones of the first edition, and I think probably the most important one of those, I think, was thinking about, and the one that's kind of relatively novel that you won't find anywhere else, is thinking about the ownership of collections. So we have this kind of, what we really wanted to look at was, it's like taking the issue of encapsulation, which lies at the root of object-oriented programming, obviously, and taking it to a somewhat more deeper level than just the general idea of, well, we'll use getters and setters instead of exposing state directly. And we discover that, we don't discover, but we explain how it should own its state entirely, and we look at the work that's required in order to ensure that the state of an object is never exposed to clients, so that they might subsequently, either by design or by malice, change it and make the object, as it were, out of its own control.
Yeah, it's certainly, we've been working with the collections in Java programming for such a long time. It's one of these things that seems obvious to us, but I guess the way I like to think about it is most Java programmers they're familiar with the idea of encapsulation. And if you have an object with a private field, then of course you will want to have methods getters and setters, but also other methods that might update that field in a very controlled way. I think Java programmers are very comfortable with the idea of fields being private to an object and encapsulating fields and whatnot. But if you stick a collection into a field, a collection is now a different object, and that's sort of somehow confusing. And so what you're doing is if you just have a getter, you're just passing around a reference. And it's very easy, if you're not careful, for an object to lose control over its internals if it simply hands out references to internal collections. And there's some examples in the book of inadvertent aliasing of collections between objects and loss of encapsulation and whatnot. And so there are a couple obvious things. Well, again, obvious. There we are. There's some things that have been in the platform for a very long time, which is the ability to wrap a collection in an unmodifiable wrapper to prevent somebody from making unintended modifications, and then also making defensive copies. It seems a little strange, but I think we did some searching, and I don't think that topic has actually adequately covered anywhere else, even though it's been an issue since day one. And personally, when we were discussing this material, I thought, well, this is so obvious. People obviously need to know that they need to make a copy here, right? It's obvious. I keep saying that word. But every so often I would stumble across code, even in the JDK, that gets it wrong. And so that sort of convinced me that, it's worthwhile to actually write this stuff down, even though it's a bit of Java lore. It's worth writing down in detail and justifying it.
Yeah, I think the basic problems come from the fact that even though in principle everybody understands the difference between, say, a shallow copy and a deep copy of an object, I don't think that they actually think about this very seriously when it comes to collections for some reason. And so I got comments on the book, including, by the way, I got a comment from Heinz Karbutz, who I know does understand the difference between shallow and deep copy. I mean, he's very expert, and he's saying, well, why do you use the word unmodifiable for these collections instead of immutable? And this is a central question in what we're talking about here, because if you don't get this difference between shallow immutability, let's call it, even though we call it unmodifiability, and real immutability, then full encapsulation doesn't mean anything to you, because full encapsulation, if you want to be serious about encapsulation, then you probably want to make it impossible for a client to mutate any part of the state graph that they get past a reference to, not just at the top level. So that issue means that to take encapsulation really seriously requires more thought than it usually gets. And if you don't take it really seriously, then you're opening yourself to the corruption of the internal state of your objects.
Talking about encapsulation and internal state and thinking about things a lot. And so one of the items that's covered in the usage guidance chapter is something called the anemic domain model. Did you want to mention some thoughts about that?
Well, the anemic domain model, that's a term that comes from a different field of object-oriented design. I think Martin Fowler invented this in the first place. And he used it to talk about domain objects which don't actually embody the domain logic. So without domain logic, they simply all of the logic of manipulating these objects has to reside in the service layer of an application. And the corresponding problem, if you've got collections, is to have a set of lists or a list of lists or a list of lists. But generally speaking, or often when you want to define a type like that, you are actually defining a domain object, and you probably want to have fields within it. So it's actually, rather than simply being bare collections like this, you probably want to define a class. And instead of saying, the example that we use in the book, for instance, is that a project is a list of tasks. So you might say then that, or a set of tasks rather. So you might say a list of projects was a list of set of tasks. But that may be inadequate, and it's actually quite likely to be inadequate if a project needs to have extra information attached to it. And the example in the book is that a project might have a total duration, which is the summed duration of all the individual tasks. Now, you could calculate that duration. It's a dynamic property, so you could calculate it every time you need it from the duration of the individual tasks. But if that's inefficient, then you're better off defining a project object and having a named type, which is more than simply a set of tasks. And this problem that I think you mentioned in the first place, Stuart, because I think you've seen it in the use of the collections framework, which is that people just simply use these bare collection types, is probably corresponds to the anemic domain type problem, and is solved in the same way by actually defining proper domain objects.
Right. As the maintainer of the collections framework, the way I see this is I get requests for people who want to have features added to the collections implementations. And so for instance, something like linked hash map, there's a lot going on in there. And for instance, so it's a map. So it's a mapping from keys to values, but it also maintains ordering. And also there's some facilities in there so that the order is updated and maintained automatically. And so the temptation is for people to say, oh, I need a linked hash map, but all I need is a variation of a linked hash map that changes the order automatically when something happens. Or I want to get a notification. I mean, the extension of this is I want a collection, but I want a callback or a notification when something changes. And to me, that's a smell, which is, it sounds like you're passing around a bare collection and expecting something to happen when somebody modifies the collection. And you shouldn't do that. You should just wrap one of your own objects around the collection and have your object contain the collection. And then you can define exactly the right methods on it that you want, that do exactly what you want. And that's the antidote for the anemic domain model.
Yeah, and that actually overlaps quite nicely with something that we also discussed in the length in the design retrospective chapter, which is how fine-grained, how specialized do you want your collection classes to be? The people that are writing to you here saying, I just want this feature, are by implication want a really vast framework consisting of lots of very highly specialized collection classes. And so one of the issues that we thought about in the book was, well, what are you really looking for in a collections framework? And we definitely rejected the kind of framework that sort of modification would lead to.
Right. And also there are some facilities in the collections framework that facilitate extension and modification. And that's another thing we do spend some time on in the usage chapter, which is the fragile base class problem. So sometimes people do want a variation on one of the existing collections. And so they reach for the first thing that they're accustomed to, which is subclassing and inheritance. And they can easily get themselves into trouble that way because they override methods until the implementation does what they want. And unfortunately, that exposes them to fragility if the superclass changes. Like when they upgrade the JDK, the behavior of superclasses might change and affect subclasses. And then that will potentially break the program. And so the collections framework contains a set of abstract classes with abstract in the name, and they are intended to be overridden and subclassed. And you can, if you want to provide customized behavior, that's the right extension point to do that. And that avoids the fragile base class problem.
Yeah. I mean, this is something, I mean, I knew about these abstract classes for a long time. And I also knew about the fragile base class problem. But it wasn't really until shortly before writing the book that I realized quite how well designed the abstract classes are in the collections framework. Josh Bloch, who wrote the collections framework and then went on to write, as we know, Effective Java, explains in Effective Java how important it is that classes for extension should be designed specifically for it to be extended. And in fact, if you go and look in the collections framework, you see that he really implemented his own advice very, very capably there. They really are very well designed, and it's very easy to extend those and get new collection classes which behave in exactly the way that you want, with exactly the difference that you want from the standard implementations. It's a really nice piece of work, and it's not nearly well enough known.
Yeah. Yeah, that's another thing. As a maintainer of the collections framework, I do get feature requests, and occasionally a feature request, I'll look at it and say, well, I can understand why somebody wants to do that, but that the collections framework doesn't need to be enhanced to provide that feature. It's easy to provide it yourself by overriding by subclassing abstract list and writing this method. And then it's easy for programmers to define whatever custom features that they want in extending the framework that way. So you did mention another one of the new chapters, which is the design retrospective. And so I think one of the big topics we covered in that was this notion of the lack of read-only or so-called immutable interfaces and the use of unsupported operation exception. I think we probably should mention that, since that is a fairly big topic.
Yeah, well, it's a big topic because people still keep on arguing about it. I mean, 20 years after the introduction. No, more than that, of course, more than that, nearly 30 years after the introduction of the collections classes. People are still saying, why do we have unsupported operation exception? I think of this as the unsupported operation exception problem. And because people hate this, and they say, well, an interface ought to say what it is you're able to do. And they cite the interface segregation principle,
right, yeah.
Which is a standard principle from object-oriented design, which says that clients shouldn't have to know more about the capability of a library than what they need. In other words, the interface should be narrow enough that it's useful in its totality to a client. And of course, unsupported operation exception, I mean, the idea that does indeed break that principle. So we had to look fairly carefully at how you might have evaded this problem. And there's a significant number of conflicting forces involved in the design of a collections framework. We talk about this a little bit. So, for example, you want to keep it reasonably small. You don't want to have unsupported operation exception. You'd like to have the names of the types reflect their function, and so on. So, and it turns out that the different alternatives that you might consider are none of them anything like perfect. And indeed, the other frameworks that we looked at, Guava, for example, or the Eclipse framework, they've made different design choices, and these choices are not bad ones, but none of them solve all of the problems that we're talking about, because some of these are just like conflicting problems.
Right. That's definitely something that people have complained about over the years. And when the original collections framework was introduced in JDK 1.2, so that would have been in 1998. So it's not quite 30 years, but it's getting up there. It was several years before the first edition was published, the first edition of the book. But just to recap for people who aren't totally up on this, we have some collections are modifiable and some are unmodifiable, but they use the same interface. So if you have a list, then you can add things to it. But if you have an unmodifiable list, you still have the same list interface, and it has an add method. And so what happens if you call the add method on it? Well, it throws unsupported operation exception. And so this does, on the face of it, violate an object design principle, the interface segregation principle. But I think it raises a bunch of other questions, which is, how do you know whether or not you can modify a particular collection? And shouldn't there be a way to check to see whether you can modify a collection? And I think that actually leads back to something we discussed a bit earlier, which was ownership of collections. You should only be modifying things that you own. And so if you own it, you know that it's modifiable. And so in practice, this is not much of a problem unless your ownership of collections is not out of control. And occasionally people will complain about this, but they'll say things like, well, I'm trying to modify a collection, but sometimes it throws unsupported operation exception. And so that raises a whole bunch of deeper questions, which is, well, where did that collection come from? And if you got it from somewhere else, maybe you're actually trying to modify somebody else's internal state. So, but it's unfortunate because the type system is actually not helping you solve this problem. You need to use coding conventions to deal with this.
Yeah, well, so people think that coding conventions are kind of inferior, that type constraints ought to tie everything down. But one of the things that we found in writing this part of the book was that a type hierarchy is only one way of constraining what collections should be able to do, and contracts are actually are very powerful. What you're calling coding conventions, but actually what I'd prefer to call contracts, because it sounds better, and it's more legal, and it's better defined, and of course should be properly documented. And contracts are actually a very interesting example of the way that constraints can move between a type hierarchy and a contract. Is to do with the sequence collections. That was an idea which was often enforced by contract in many of the scattered collections that became sequence collections. But when that interface was introduced, the types that implemented it became constrained by the formal type system. But the formal type system is only one way of enforcing semantic constraints, and quite often it's not even necessarily the best one.
Right. Yeah. And I think a classic example, which we do also cover in the book, is immutability. And so it's very easy to say, I have this type and it's immutable, but at least in Java, there's really nothing preventing somebody from making a subclass and adding a mutator method and making the thing mutable. And so that's not really something that you can enforce in a type hierarchy, unless you add additional constraints on it, such as making the class final or making a sealed interface, which are actually, well, it's always been possible to make a class final, but the notion of a sealed interface is something that's actually relatively recent. I don't remember exactly when that went in, but it used to be the case that the instance creation of interfaces were out of the control of the library authors, and anybody could implement an interface. But that's not true. That's not true anymore. On the other hand, if you seal an interface, that also means that you're shutting off third-party extensions. And so there's the trade-off there, which is in many cases, we do want frameworks such as the collections framework to be extensible by third parties.
Yeah.
So let's see. I think there's maybe one small issue we can tackle before we wrap this up, which is the idea of null handling in collections. Is that?
Oh no, that's too.
Yes.
That is too painful. That is too painful. This was perhaps not the most enjoyable topic to write about. Well, I mean, really, I should hand this over to you, Stuart. I mean, you're supporting the collections framework, and of all the design issues that we talked about, I mean, I think we go into some detail on the thing that we've just been discussing, the issue of the type hierarchy and the ways of constraining collection behavior, and I think it's possible to make a reasonably good case to defend the design decisions that were made in that area. However, when it comes to null, I think you would have to be an extremely good lawyer to defend the inconsistent treatment of null in the collections framework. It's really not its proudest aspect.
Yes, it's quite far from its proudest moment. Just a brief history: the so-called legacy collections, vector and hashtable, which came in JDK 1.0, disallowed nulls, and then the main collections framework introduced in 1.2 allowed nulls in most instances, such as hashmap allows nulls. And then the concurrent collections in Java 5 disallowed nulls. And we've kind of sort of kept with that. But the fact is now we have multiple implementations that implement the same interfaces that have different treatment of nulls. And the contradictions there are just too many to list here, but there are contradictions in the specs and inconsistencies are rife. And so, yes, as you said, it's not the proudest moment of the collections design, but this is one of the messes that has built up over the past 25 plus years.
I think we should try to end this. We should try to end this conversation on a more cheerful note than the treatment of nulls in the collections framework. I mean, looking at the design retrospective on the whole, I think that the decisions that were made are, I think, the introduction of the design of the collections framework, which was done in one go, really, by Josh Bloch, is pretty remarkable. I mean, it was a considerable achievement, and it stood up very well for nearly 30 years. So I think we can say we should look at the good points of this. And I'd like to say about the book that I think we've been able to document that in a lot more detail than is usually done, and shone some light into some not well understood corners of the framework that could be pretty valuable for the development community in the future. So, I feel like the book overall, I think it's kind of worthwhile piece of communication with the community about both generics and collections, and looking at them in the light of, well, a lot of experience since they were introduced. So, yeah, well, I feel like you should buy the book, fairly yes, obviously. Right. We've talked about some of the topics here. There are only a few of the topics in very, very broad outline. There's a lot of detail on all of those. So I would recommend, if this has been of any interest to you, then you should take a look at it.
I think so. I think you're quite right on both of those points, which is the collections API has held up, I think, quite well over multiple decades. And when I look at other APIs which have come and gone over the years, I think people still make effective use of the collections framework today, and there are some still ways we can continue to evolve to continue its usefulness. And yes, we cover a lot of additional details in the book, so I'd recommend you go out and find the book wherever popular books are sold.
Well,
all right. Well,
yeah. Thanks very much for the conversation, and thanks obviously for all of your work on the book as well, Stuart.
Okay, and of course you're the author, and so you put the lion's share of the effort into it, and so congratulations on delivering the second edition of this book after so many years and so many updates.
Thanks very much.
Thank you.
Bye.
Bye-bye.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.